Hello everyone, welcome back to the Project Integration Management. Today we are discussing Chapter 6, Developing a Project Schedule. Excuse me, we are using a book called Project Management, The Rangeless Process. This is owned by McGraw-Hill. 2021 is the copyrights. It is owned by Eric and Clifford Gray in terms of the author. Okay, let's start with Chapter 6. Where we are now, we are at chapter 6, which is project network. There are a number of learning objectives for this one, which is about 6, understanding the linkage between WBS and project network, diagram a project network using Aeon methods. Number 3, calculate early, late, and lag activity times. Number 4, identify and understand the importance of managing the critical path. Number 5, distinguish a free slack of total slack. Number 6, demonstrate understand the application of lags in comparison project and constrain the start of finish if an activities. In chapter outline, we're gonna discuss the 1 to 9, which defining a project network from a work package to network. Number 3, constructing project network. Number 4 is activity on Node Aeon, the fundamentals. Number 5, network computing process. Number 5, using network computation process. Number 6 is using forward and backward pass information. Number 7 is level detail of activities. 8, practical consideration. And 9, extending network techniques to come closer. Okay, let's discuss this in detail. Defining project network. The one is a graphic flowchart depicting a project activity that must be completed. The logical consequences, sequences, the introductions of the activity be completed at the times of the activities to start and finish along with the longest path through the network, the critical path, provide the basis for scheduling labor and equipment, enhance communication among project stakeholders, provide estimate project durations, provide an estimate of provide the basis for budgeting cash flow, identifies which activities are critical and should not be delayed, highlight which activities to consider for compressing the project duration, help managers to get and stay at the project plans. This is a project from work package to network. The lowest element, circuit board design, cost account, production cost account, test cost account, service account. This is a typical one. This is activity network, build network package from A to all the way to K. This is in terms of specific documentations. For here, we can look at the system here with specific documentations from A to K. From photo 1, software preliminary, final photo 2, final software 2, and then do a test. So this is a typical organization here at the lowest level. So this is what, in terms of the flow of the package network, okay? And then number 3, constructing a project network. Terminology is that an element of project that requires time but may not require resources. Activities that can take time at the same time. It desire burst activities, an activity that has more than one activity immediately. Merge activity, an activity that has more one activity than activity immediately pursuing it, more than one dependency around flowing it. That's the key card, merge activity, okay? Path sequences of connected dependent activities. Critical path is the longest duration to the network. 2 processes. We're using an activity on node, which is use a node to depict the activity, or you're going to use an activity on arrow. Use an arrow to depict the activity. So it's like a work flow chart. That's basically what it is. Okay, the approaches is using a workflow chart. One is using a node, the other one is using an arrow. Okay. Basic rule to following project network. Number 1, network the flow typically from left to right. An activity cannot begin until all preceding activities have been completed. That's the key part. A good example, when I do an IFRS project, all the components of the balance sheet must be in play before you can construct a full balance sheet item. A good example. One good example item will be when we are doing an IFRS project. Just one module, let's say account receivable. Make sure that all account receivable account from all the companies must be put in play into the landing zone in order to generate a account receivable numbers. Okay, that's the key part. Okay, number 3, arrow or network indicate precedent and flow and can cross over each other. For each activity should have a unique identification number. Number 5, an activity identity number must be greater than that of any activity that preceded. And number 6, looping is not allowed. That's the key. Looping is not allowed. You cannot loop it. You have to go through it. Conditional statements are not allowed as well. Where there are multiple start, common start node can be used to indicate a clear project beginning on the network. Similarly, a single project end node can be used to indicate clear endings. Okay, this is at the activity node, A, O, N, fundamental. That's the key part. A, go to B, go to C. A is represented by nothing, B is represented to A, C is represented by B. Okay, this is a good example. I'm giving you an example of this particular case. When I was in IFRS project, I mentioned to you earlier, we are doing an account payable and account receivable. So all account payable and account receivable has to start here from zero, from 20 system. From 20 system, we go to the landing zone, which is the B part. Okay, from the B landing zone, we're gonna pull the data for account payable and account receivable at the final part. That's the key part. Okay, X is Y and X are preceded by X. So this X is the basis. So okay, Y and X, Y and Z can begin at the same if you wish. X is the burst activity, so it's the basic is the X. Another example, J, K, L can all begin at the same time if you wish to do, but not occur simultaneously. But J, K, L must be complete before M can begin. That's the key part. So all of this. So account receivable, account payable, and all the things, all component of balance sheet has to be completed in order to produce a balance sheet numbers. That's the key part when I did it. Okay, XZ is preceded by X and Y. AA is preceded by X and Y. This is another configuration, different consideration. Okay, this is a network automated warehouse. A is the activity to H. A, which is defined, there's no preceding activities. AB is the design team. C is the design software. Preceding will be A. This is another typical order picking system. Okay, this is the code software, which is preceding activity B. Is the build and test hardware preceding by C. F will be the flow pattern requests preceding by activity will be C. G is the test hardware preceding by D. H the integration preceding by E, F, G. So this is the order packing system based on the preceding activities. Shows you how the flowchart has to go done, have to be done. Okay, from A, B, C, D is defined. We have defined. So number A, you need to define the requirements. Again, once you define the requirement, you assign a team. That's what I did. Okay, and before define the requirements of account, let's say account receivable model, we assign a name and design the hardware. This is a typical automated warehouse order packing system in the particular example. Once you do that, let me just go back, make sure I didn't touch quickly. So A is the divine, A is the base, B and C. From B and C, go to the D code software and the test hardware, and then do integrate the system. Okay, but this can only be done when C, E, and F is done. Okay, so from C, it has to be build and test hardware, and then F, the flow pattern request that integrate the system. That's the typical automated warehouse in a complete network system. The flowcharts. 6.5. Network computer process forward pass, earliest time. How soon can the activity start? Early start, which is called ES. How soon the activities, we call it early finish. How soon can the project finish? Expected time. Backward pass, latest time. How late can the activity start? LS. How late can the activity finish? LF. Which activity can the activity pass, which is CP. How long can the activity be late? That's the key part, okay? Now, network automation system, so example A to H here, from defining requirements, activities, let's say 10 days. For B, it's another 5 days, okay? 25 for C. From D is 20 days. From E, about 50 days. From F is 15 days. G is 13 is 35 days. H will be 15 days. So it gives you an example of the flowchart, how it goes about. So when you define the requirement in terms of active or node network from A to B, C, so it gives you the thing here, give you an idea of the days that you have to do. Early start, which is this one, okay? Legend side here. That just give you an idea of the flowcharts of going on, okay? So they give you an idea. So here you're gonna plug it into the node automatic node here, okay? From there, you're gonna put in the design team, allow integrated system, give you an idea 10 here, 10 here, 15 here, this is 10, okay? 5 will be 15, 15 here, plus 20 will get 35, 35 here, okay, plus 35 you can do 70 here, 70 here, okay? That's how it goes. Defining as 10 here is 10 here plus 25 because 35 is the beginning. You're going to do 50 here, 85, so 85 here. So from here, hard design software, you got 35 here, therefore pattern equals to 15, 35 to 15, it becomes 50, 50 here. So total 70, 85. The earliest you can do, even though here is finished early, 70 days, here is finished early, 50 days, but here is 85 days. So 85 plus 15 is 100 days. So it goes to go. So the latest one. So it gives you an idea of the days that you can do to finish the integrated system. Although the other two here, the first one is at 70, the second one is 85, the third one is 50. They cannot do because here you have to do 85 days. Okay, I'll give you an idea. Forward pass computation. Add activity S along each path in the network, ES plus duration equal to EF. Carry the early finish to the next activity where it becomes the early start ES unless the next preceding activity is merge activity, in which case the largest early finish number of all its immediate predecessor activity is selected. Okay, so give you an auto idea situation here is 100 time. Gives you a defined requirement again. 100. That's the key part. That's the earliest one. If you take a look, the previous one I mentioned to you, 85 plus 50, even though this is early, but it cannot be finished. Why? Because this one is longer. Okay, that's the idea. Okay, so if you go back here to the original one. Okay, for backward pass computations, subtract activity times along with each pass starting with the project N, which is FL minus duration, we got it LS. Carry the late start to the next preceding activity where it becomes the late activities LF, unless the next succeeding activity is the burst activity, in which case the smallest late start number of all its immediate successor activity is selected. Okay, so how are you gonna go about 70 here? Look at this. This is the TS. This is the TS activity smallest late start. Late start here you can see the early start, late start TS. Okay, this is the key part. This is the term that you're going to put. Okay, then tell total slack. The term is slack of flow times. Okay, tell us amount of time an activity can be delayed or not delayed in the project. How total slack is how long activity can exceed the earliest finish time. Let's start start without affecting the project end date or impose completion date. Or is simply the difference between like LS and AS, which is this one, LS minus AS, which is SL, total slack, short slack, and then between LF and AF, which is SL. Okay, the free slack is the amount time of an activity can be delayed without delaying any immediate following successor activity. It is how long an activity can exceed its early finish date without affecting the early start date of any successors. Allow flexibility in scheduling scarce resources occurs only when at the end of change activity where you have the merged activities. Okay, the critical path. There is a network path that has the least slack in common, is the longest path to the activity network. It is the shortest expected time in which the entire project can be completed. It is important because it impacts completion time. It is where you put the best people on. It is where you pay extra attention when doing the risk assessment. It is where you don't look when other managers are asking to borrow people or equipment. It is where you look when you don't have time to monitor all activities. Sensitivity. Network sensitivity is the likelihood the critical path will change once the project is initiated. A network schedule that has only one critical path and non-critical activities, the angel signal slack should be labeled insensitive. Okay. And then practical consideration with the network logic errors, activity numbering, use of computer developed networks such as Gantt charts, calendar dates, and multi-start and multiple projects. So this is the illogical loop A to B to C. Okay, this gives you an example: automated warehouse picking system network, define requirements. Okay, and then assign the team to 10 days here, 5 days here. Design software 25 days, coding software which is 20 days, build and test with 60 days. The firm pattern requirements are 15 days. Test software is 35 days. Integration will be another 15 days there. Okay. When you look at this and to put it in the Gantt chart, you're going to put it here. The Gantt chart is going to show you where it's supposed to be. Okay, this is automated warehouse system Gantt chart that is put it in play. Okay, from define requirements, assign team, design software. So it gives you the take 0 days, 15 days here, and then here 0 day design hardware, another 15 days. Okay, and then 0 days here, 35 days is 15 days. So it gives you a flow of integrated system all the way to what? From January start, we're going to finish in May at the end of the actual date. And then 6.9, extended network techniques can come closer to reality. Laddering is an activities. Laddering means an activities are broken into segments so that the following activity can be begin sooner and not delay the work. And then use of lag to reduce the schedule detail and project durations. Lag is the amount of time a dependent activity must be delayed to begin or end. Lag activity are broken down to reduce the delay in the start of successful activities. Lag can be used to change phase to start to finish, finish to start to finish, and combination of relationship. This is give you an example of finish to start in Aeon network, okay? From timeshare to Aeon network. And then finish to start relation, submit order, receive the goods, start the relationship, film here, record audio, code and test, okay? Times 1 here, leg 1, leg 3, lay pipe mile, refill 1 mile. And then the other one, new product development process. A good example here will be traditional sequencing. This is a sequencing approach, which is from product planning to system engineering, engineering design and development, procurement, manufacturing production, and quality assurance, and then doing a release. It's typical the sequential approach, but the Concur one is different way around. From product planning, go to system engineering. Engineering, they step up. They all step up. That's the key part. Okay, here is all the flowchart system. This is a step-up system. For use of lag from prototype to lag 1-4 to testing, finish to finish relationship. This is from start to finish relationship, testing to document system documentations. Okay, for code combination relationship. I am using a network using lag. This is a typical flow chart. The charts for the network lagging system. Okay, from here design all the way to system documentation. From here design system, install software to software. Okay. Hammock activity spent over a segment of project has a duration that is determined after the network is drawn. Is very useful in assigning and controlling the right project cost. We use the aggregate section of the project to facilitate getting the right level of detail to specific section of the project. This hammock here is the hammock activities. So that's the key part in terms of the hammocks. Give you a legend, the detail of the legend. Okay, so let's look at the definitions. Okay, key terms: activity, activity on arrow, activity on node, burst activity, concurrent engineering, critical path, early time, free slack, FS, Gantt chart, hammock activity, like relationship, early time, merge activities, path, sensitivity, and total slack. Okay. So let's move on to the next one. This is McGraw-Hill, owned by McGraw-Hill, okay? And then look at the package network and give an example here of the organization from work to package network. In the text alternative, gives you an idea of arrow from the lowest element to circuit board design costs, okay? Production cost here, test cost account, software cost account, all the way. And activity network and broad network package from here can give you an idea of the total chart. The automated air warehouse picking system system schedule table. Okay, and then let me see if we can have yeah, that's basically conclude the chapter. So I'm gonna upload this in YouTube as well as an Edpuzzle. You can do an interactive learning in the Edpuzzle in the My Guru 8888. Thank you. Bye bye.